So it's awesome to catch up here, Wei. It's been a couple of months since we've actually seen each other. Tokenomics, the hottest topic that we both love and share a passion for. What's the latest and greatest in terms of the last few months? Because nothing else matters before that, really. So,
Yeah, that's a really good question, Val. I mean, so just for background, I joined SemiAnalysis maybe a little bit, half a year ago now, and basically to bring the vision of SemiAnalysis to its fruition, right? From hardware all the way down to software, the models, and the tokens. And I think people have talked about this ad nauseum, but like we're basically entering a different age of software, where software is going from maybe zero or minimal marginal costs to relatively high marginal costs. And so the economics of serving tokens, the economics of these models in terms of the cost per token they produce is extremely important. And there's a lot of business model considerations when you are serving models as a service.
yeah. And the thing I love to dig into with you and colleagues of yours like Dan Ishbal are the layer cake, right? So there's a GPU provider view of tokenomics. There's definitely the model provider view of tokenomics, model builder view, the agent, consumer of tokenomics, and then like the end user, whether it's an enterprise or consumer end user. So it's like different, different audiences have different interests or priorities. How are you seeing that kind of play out, in the industry today?
Yeah, I think like any development of a new industry or business model, people kind of, fixate or focus on the easiest things first, right? Like, so for now, a lot of businesses have come out, bought a bunch of GPUs, renting them out to, model runners, people either training models or, eventually inferencing the models that they train. And they pay by the hour for GPU. Yeah. And what are they looking for there? They're looking for uptime, they're looking for service level, service quality, they're looking for the user experience, what kind of virtualization software you have sitting on top of bare metal, all those things. But as you mentioned in the layer cake, we are definitely seeing more and more companies focus on the layer below that, which is once you do have a model, ideally like an open source model that you're hosting, right, where you basically don't have to pay the API tax to anyone, right? How do you serve it efficiently, and how do you design your infrastructure setup for the workloads you expect? I think the really interesting thing about tokenomics is, and I think you and I have talked about this and understand this, you can almost print any number you want. You want to produce a 2-cent token, you can produce a 2-cent token. You want to produce a $10 token, you can produce a $10 token. It all really depends on a few things, right? Which is, how fast the user is experiencing that token. So that's tokens per user per second. Yeah. And then how long you're making your user wait for that first token out, right? Which is time to first token. And there's this great economic trade-off between basically how fast your user experience is versus how many tokens are output by a given accelerator GPU per second. Yeah. And I think that's kind of what businesses are trying to figure out today.
Exactly. I think the ends of that spectrum are interesting. You can have the private jet experience for tokens at a certain cost, or you can have the public, transit bus experience at a much lower cost, but definitely different quality of service, different experience. Now, one of the underlying mechanisms for this is prompt caching. We talked just beforehand about this. Let's dig into this a little bit. Like, we see at least on the surface that the commercial labs now, the Anthropics, the OpenAIs, have distinct prompt caching pricing with different levels of complexity we should talk about. It seems like the open models and the open model providers aren't implementing or pushing prompt caching as much. What's your take on that? Because you're seeing a finer level of granularity on this.
Yeah, no, I think it's a great observation. I mean, just to level set everyone, I think actually prompt caching as a price discriminator or like a discounting mechanism really only appeared like maybe second half of last year. So it's really novel. But just taking like 2-3 steps back, so what is token pricing today? Token pricing today actually looks a lot like the hardware utilization required to produce a specific token. I'm sure if you go on Anthropic or OpenAI or even OpenRouter, right, you can see there's a different price for an input token versus an output token. And then there's this new token that people are classifying, which is like a cache-free token, right? Or prompt, cache tokens. So from that perspective, what all these prices really reflect is the different kind of compute intensity of each token. And prompt caching is an extremely important and extremely influential economic factor when it comes to the total cost of any given stream of tokens that you're consuming. I'm sure you have a lot to say on this, but it's basically a way to incentivize users to craft their prompts or craft their workloads to make the most economic use of the hardware.
Yeah. So to that point, there's a lot of, I would almost say ironically, manual cache management in these agentic systems as we're developing them, especially as we're deploying them. What are your thoughts? You know our opinions on this around augmented memory and the impact it could have, but what are your thoughts around like the practical benefits of taking what seems to be the state of the art of prompt caching, which is maybe paying a premium for an hour's worth of caching? What if we were able to offer a day? What if we were able to offer a week or a month of prompt caching at, pick your cost point, higher or lower than today? What would be like the benefits of that for the workloads you're seeing and maybe ideally the agentic swarm workloads?
Yeah, I think it's a good question. So, basically right now, the way it works is the API pricing and these models kind of grew up in this world of chat, right? And chat, like, you can get a few thousand tokens in, maybe a few thousand out, or more with reasoning. And, users can or can't. Sometimes they want to keep what they were talking about. Mostly people just press the new chat button, right? And you basically refresh everything, you get to re-prefill.
One or two turns, a few turns.
Exactly. When it comes to agentic workloads, or we describe it like swarms, right? Where you have like different models operating on different parts of the context and doing different things with it. There's an enormous, I think, corporate value to being able to not constantly refresh all these tokens re-prefill, because for every token that has to be pre-filled, that costs money, right? And for every token that has to be decoded, that also costs money, more money, in fact. And so to the extent you can basically get tokens for free with cache tokens, with prefix cache hits, then you don't need to pay for those tokens. And as context windows explode, as the, call it like the token length per query explodes, there's actually like increasing value to be able to find all those tokens with a prefix hit rather than with fresh prefill. And what you described, which is storing the tokens over multiple days and months, I mean, I think that's super helpful for enterprises because then they can basically just pick up where they left off, right?
And it's cool, like, Manus, very popular agent now, published a pretty popular context engineering blog a couple of months ago, and they said like the #1 indicator of success for agents is KV cache hit rate. And what we've seen in our models is the ability to basically take that, incremental difference between 50 to 60%, 60 to 70, and so forth, all the way up to 90%. That has like an exponential benefit. It's a classic exponential graph. So what are your thoughts around how systems of the future, agents of the future, are going to depend on these kinds of cache hit rates, on agent swarms? And then we'll table a reinforcement learning question for after.
Yeah, I mean, like you said, free tokens, right?
Yeah.
Like,
yeah.
I think one common misconception people have is that, because they look at the prices of these tokens, they're like, oh, output tokens are really expensive, like 10x expensive. That must be the thing that really drives things. But if you look at actual like workloads for the API services and stuff like that, actually it's the input workloads that dominate.
Absolutely, the ratios are like hundreds of input tokens to one output token. It's crazy.
Yeah, for a lot of these agentic workloads, So like I think people are still anchoring on this like chat interface, which is like 2 to 1, 3 to 1, 4 to 1, and nowadays we see like 10, 50, 100, and the total sequence length is very long. So the input token price has huge influence on the total price of your tokens on average. And the more of those that are, at like a 90% discount or like essentially free, right, if you own your own hardware, the lower your overall token cost would be.
Yeah, that's a cool point. And so at the keynotes this morning, it was really refreshing to see Marco, who's the PyTorch product manager at AMD, really mapped the reinforcement learning challenge as flops in memory and showed how, again, it's very, very memory bound.
Yeah.
So what are your thoughts on that in terms of, it seems like today the latest trends as we wrap up 2025 is that reinforcement learning seems to be the next step to the next milestone, the next step function of AI, perhaps even AGI. So given that it's really inference bound and decode bound, what are your thoughts on tokenomics is really advancing the whole field and science of AI?
I don't know. I don't know if we have enough time for this, but I mean,
summary sauce.
Yeah, the summary is, look, there's 3 ways of scaling model performance, right? Roughly speaking, there's the pre-training, the classical, more flops, more data. There's been post-training with all kinds of techniques, supervised fine-tuning, RL, And these methodologies have actually been a bigger driver of gains of the models recently, because you can basically, mold the model into, against like a set of verifiable tasks. You can either verify it with a grader or with a LLM as a rubric, and make the model more practically useful. And then there's test time compute, right? Like the more time you spend testing, or like you can see some of these models shoot out multiple different prompts, the same prompt, and try to find the best answer. Reinforcement learning requires forward passes. Basically, you're producing a lot of traces, a lot of rollouts, and this is very much an inference workload. And inference workloads, as we've discussed, are very much memory bound, right? Because the decode tokens being produced are typically bound by the memory communication rate between chips. So, yeah, I think with better memory caching techniques, you can drive the costs down of this technique, and you can reduce your overall inference spend for essentially training, right?
And I would say accelerate those RL loops as well, and just bring new checkpoints, key checkpoints to market faster, which is really cool.
Yeah, no, it's all about throughput at the end of the day.
So let's wrap on InferenceMax. Amazing, product service. I'm not sure exactly how you categorize it. Becoming really widely followed by the industry. It had a great first impression, great reception by the industry. And we know it's version 1.
Yes.
And we know there's so much more we can do. Why don't you just briefly outline what it is, and especially what the challenges are in terms of what we discussed, where we want to take it in version 2, and how we can fix some of those right here, right now.
I don't know about right here, right now, but so InferenceMax is really cool. So SemiAnalysis, as a firm, we started off, doing research on semiconductors, but recently we've really started focusing on like, what are the things that matter for people deploying AI today, right? Like both from a bare metal rental perspective, and now for InferenceMax, like from a model deployment perspective, right? What hardware setup is the most efficient for delivering the most software or model?
And there's so many options there, right?
So many options.
It's quite a recipe they have to figure out. So
yeah, and so we try to pick a few models that we think are representative of the market today. So we have GPT OSS 120B, which is like a 5 or 6 billion active parameter model, and then we have DeepSeek R1, which is like a 37 billion active parameter model. So we try to match the more popular model architectures with what we think are the most popular accelerators today, right? Today we have B200, GB200, the MI series, all the way up to 350, and we have the current system setups. We're looking to expand more. So what is the methodology today? We basically have a 3 flavors of input-output sequence length. We have 2 models currently, and we have FP4, FP8, those different quantization. And then we measure all of these unit economic metrics across a sweep, all the sweeps of hardware across an array of what we call interactivity. Interactivity being tokens per second per user, right? So basically what you as a user experience. And you can see this beautiful economic trade-off in terms of the throughput you can get out of your GPU versus the throughput a user expects, right? But you mentioned shortcomings, or what it could be.
Opportunities to improve.
Opportunities to improve. Yeah,
we'll connect what we just talked about in
Yeah.
terms of the input-output token ratios we're seeing in the real world today, to how we want to use this really amazing foundation of InferenceMax to represent that.
Yeah. So a lot of people, when we talk to actual endpoint providers, they're like, I just look at the 8-to-1K because that's what we see, right? We see 8-to-1, and others are like, well, actually, I'm seeing a lot of agentic use cases that are like 50 or 100. And you're like, okay, well, it's a different discussion. So there's things we can do to improve the different input-output lengths we use. The other thing right now, we're kind of using random sequences right now, so there is no KV cache hit. So we're not really measuring, let's call it like the real-life performance of these machines. If
System prompts and all sorts of things in there,
System prompts and things like that, but also just like, we're just not maybe fully capturing what a real use case would look like, because we don't have that yet. But those are all on the roadmap.
And those are, again, to be able to take InferenceMax in this direction. It's not a commitment, obviously, but it's very resource intensive, right? So what are your thoughts around that? I've got some proposals we can just openly talk about here and see if we can start something and recruit some sponsors. But what are your thoughts around the requirements to go from InferenceMax 1 to this kind of version 2?
Yeah, I think the first thing is you got to bribe me. No, I mean, so we've been fairly open with our compute partners on this, and AMD and NVIDIA have been huge supporters of this, both from a software engineering resources and also hardware resources side. And we utilize some neoclouds as well for compute resources. I think the biggest thing that can help with us is engineering resources, right, on our end. So if there are people out there that are very interested in producing what we think will be the definitive benchmarking for AI performance, you should reach out to our careers page on SemiAnalysis. We're always hiring. But beyond that, I think it would be nice to bring in additional hardware partners. Because this is live benchmarking done every day, and it's super transparent, super open. There's no decision by committee. It's open source. Everyone can look at the code and make your own judgments.
So that's the cool thing here is, again, there's lessons to be learned because some of the resource requirements, those GPU to complement the software, the GPU resource requirements are pretty significant. They're like bordering $10,000 a week type of requirements. Sorry, 10,000 a day, about 50,000 a week. And some of these benchmarks even exceed like, a day's worth of runtime. So one of the things we can consider doing is what worked with Kubernetes in the early days when I was part of the Cloud Native Compute Foundation and helping form that is when you have a good governance model with benchmarks that are relevant in the real world, credible by actual end users and customers, that all the vendors who this strong governance model can agree upon, there's a way to draw a lot of sponsorship and a lot of funding to afford this kind of InferenceMax too. So that's something I think is really worth pitching here is, can we make this happen?
Yeah. No, that's a good point. And, while we do appreciate the offer of money being thrown at us, I think for us what's important is to remain unbiased and to strike a healthy balance, right, between securing these resources we need to run this benchmark, but also to produce something that the whole industry can agree upon as being, a fair, balanced assessment.
And so it'd be a nonprofit foundation people be throwing money at, right? And you could be chairing it, et cetera.
Yeah.
And that's the point. So
and maybe we can convert it into a PBC one day and raise.
Yeah, exactly. Do the Sam Altman thing. That's a fun note to end it on.
Cheers.